So let's start with learning objective. We have 4 here, which is understand basic logical operations, get to know each of the 12 laws of logic, simplify logical expression by using the laws of logic, and prove logical equivalences using laws of logic. So first, let's understand basic logical operations first. Number 1 is negation. Negation is statement reverse its truth value. For example, if a statement is true, its negation is false. If a statement is false, its negation is true. Symbol right as this. And for example here we have P equal to it is raining, and for negation P, it is not raining. So here is the truth table for negation. When P equals to T, negation P equals to F, and when P equal to F, negation P equals to T. So for second basic logical operations, we have conjunction. Conjunction is true only when both statements are true. Symbol read as P and Q. So for example here we have P equal to I am hungry and Q equal to I have food. So P conjunction Q equals to I am hungry and I have food. So here is the truth table for conjunction. When P equals to true and Q equals to true, we have P and Q equals to T. So other than that, all of them are false. So for example here when P equals to T and Q equal to F, we got F, and when P equal to F, Q equal to T, we also got F. So when both statements are false, we also got F.
Next, we have disjunction, meaning a disjunction is true if at least one of the statement is true. The symbol is P disjunction Q. It is read as P or Q. We give you an example. Let P equals to I am hungry. Let Q equals to I have food. If we let P or Q, it is equals to I am hungry or I have food. From the truth table, if both of the variable is true, then the truth value is true. And if either one of the variable is true and the other is false, and the truth value is also will be true. But if both of the variable is false, then the truth table will be false. Moreover, implication, meaning an implication means if P then Q. P in this situation is a hypothesis and Q is the conclusion. It is false only when the hypothesis is true and the conclusion is false. In all other cases, it is true. The symbol P arrow Q read as P implies Q. To give you an easy example to understand, let P, which is I study, let Q equals to I pass the exam. If we let P implies Q, if I study, then I pass the exam. As we have learned before, in the truth table, the truth value will be false only if the hypothesis is true and the conclusion is false. Last but not least is biconditional, meaning a biconditional means P if and only if Q, also written as P if Q. The biconditional is true only when both statements have the same truth value, either both true or both false. If either one of the variable is true and the other is false, the truth value will be false. The symbol P if Q read as if and only if. To give you a perfect example, let P equals to I study and we let Q equals to I pass the exam. Let P if Q is I study if and only if I pass the exam. We can see from the truth table, the truth value will be false if either one of the variable is true and the other is false.
Okay, Assalamualaikum. Today I will explain 12 important laws of logic in simple terms. These laws help us understand how logical statements work in the mathematics and computer science. First, double negation law. If we say not P, it's the same as just saying P. Double negative cancel out. And for the second, De Morgan's law. Not bracket P and Q means not P or not Q. Not bracket P or Q means not P and not Q. Next, commutative law. The order doesn't matter in and or. P and Q is the same as Q and P. P or Q is the same as Q or P. Next, associative law. If we group with bracket, the logic stays the same. Grouping P and Q, then and R is the same as grouping Q and R first. Okay, next, distributive law and distributive over or and or distributive over n. Like in MAT, P and bracket Q or R is the same as bracket P and Q or bracket P and R. For the next, implication, P implies is the same as not P or Q. This is how we usually write logical if-then statement. Okay, next, idempotent law. P and P is just P. P or P is just P. Repeating doesn't change the value. For the next, biconditional. P if and only if Q is the same as P implies Q and Q implies P. They must be true or both be false. Next, identity law. P and true is P or false is P. This show the identity value and n. Okay, next, dominance law. P and false is always false. P or true is always true. Next, inverse law. P and not P is always false. P or not P is always true. For the last, absorption law. P and bracket P or Q is just P. P or bracket P and Q is also just P. This law make it easier to simplify and understand logical statement. They are used in math, computer science, and everyday reasoning. Thank you.
Alright, for this slide, we are going to learn how to simplify logical expression using the laws of logic. Let's take a look at the expression at the top of the slide. P and Q or R, or not P and Q or R. We're going to simplify this expression step by step using the correct logic laws. I'll walk you through each step shown on the paper. Step 1. Apply the distributive law. The distributive law in a logic works similarly to multiplication in algebra. It allows us to factor out a common expression. Here, we notice that both parts of the expression share Q or R, so we can factor that out. P and Q or R, or not P and Q or R, becomes P or not P and Q or R. It is done using the distributive law. Step 2. Apply the inverse law. Now, look at the expression P or not P. This is always true because P or not P cover all possibilities. So, P or not P is equal to T. T is a tautology. The possible is always true. This step uses the inverse law, also known as the law of the extended middle. Now, the expressions becomes T and Q or R. Step 3 is apply the identity law. Finally, using the identity law, we know that T and Q or R is reflect to the self is Q or R. And this is our final simplified expression. For conclusion, the distributive law to a factor common part. The inverse law is to simplify a tautology, and the identity law to reduce the final expression. This shows how logical laws can help us simplify complex expression into something much easier to work with. And this.
Hello, I will be explaining about the simplified logical equivalences using law of logic. So, for example, the logical equivalences. that is not P or not Q or P and Q. So first thing first, we can apply the De Morgan's law here by expanding the negations in front of P or not Q, which will result in not P and not Q or P and Q. So after that, we can see the double negations on Q. So we can apply the double negations on that one, which will result in not P and Q or P and Q. After that, we can use the distributive law, which will result in not P or P and Q. As you can see here, there are the two same variables, which is P and P, not P and P. We can use the inverse law on that one, on not P or P, which will result in true. So after that, the result is true and Q. True and Q, we can use the identity law, which will result in Q. So by using all the laws given, we can simplify the not P or not Q or P and Q into Q by using law of logic. Thank you.
Okay, so here is the conclusion. By studying the laws of logic in mathematical logic, it provides a foundation for clear, consistent, and precise reasoning. These laws help us understand and analyze arguments, simplify complex logical expressions, avoid contradictions and fallacies, develop critical thinking skills, and support formal systems.